Hello, this is Mr. Stansbury. I'm going to take you through the notes for calculating probabilities. At the end of this, you should be able to say, I can use the normal distribution to solve real-world type problems. Okay? So, first things first. We have x to be the mean, and then this sigma here to be the standard deviation. We also earlier had that mu is also the mean. So either one of these, I should write that a little bit bigger so we can see that. So either one of these works fine for the mean. Okay, just wanted to show you a couple different ways you could possibly see that. Okay, so with a normally distributed set of data here, 68% of the data is going to lie between one standard deviation of the mean. So here's the mean right down here in the middle, and then there's one standard deviation below, one standard deviation above, so we call that within one standard deviation of the mean. 68% of the data should fall. Okay, within two standard deviations of the mean, so that's two below and two above, 95% of the data should lie. And then within three standard deviations of the mean, 99.7% of the data should be in there. Okay, another way to look at this, oops, was not supposed to look like that. Here we go. Another way to look at that, if you split that 34, the 68% into two, that means from the standard deviation up one standard deviation is 34, and from the standard deviation down is 34%. So same thing here. This little section here is 13.5% between 1 and 2 standard deviations, and then this last little section here is 2.35% of the data between 2 and 3, -2 and -3, +2 and +3 standard deviations from the mean, right? So again, looking back at this here, 68%, 95%, 99.7. Another way to look at that, there's 68 split into two. This is the 68 plus the extra to make up the 95, which is another 27. And then here's the extra piece there. Okay. Moving along. Example 1. The salaries of 43 ostrich babysitters have a normal distribution with X, with a bar over the top, or mu, with the mean being $68,157 annually. And then the standard deviation is 26,844. Okay, so within what range do about 95% of the ostrich sitters' salaries fall? Whew, that was tough to say. Okay, so here's how we want to look at that. Since 95% is two standard deviations from the mean, we're going to add two standard deviations to the mean, and we're also going to subtract two standard deviations from the mean to find our range. So again, the mean is 68,157, so we're going to start with 68,157 for both the top and the bottom. And then we're going to add two standard deviations to be at the top range. So one standard deviation is 26,844, so we added one to get to 95, added another to get to 121,845, and then the the smaller end of the range would be 68. Our mean, subtract two standard deviations. So there's our 68 minus 26, and then subtract another 26, we're at 14,469. So the range of about 95% of the ostrich sitter salaries should be between 121,845 to 14,469. Okay? Okay. Let's do this. Let's take a look at an example here, but maybe before we do that, let's take a quick comedy break.
I'm just old. That's my problem, man. I'm officially an old dude. I don't have the patience no more. It's the first thing to go when you get old. I'm officially an old dude. I know what you're going through, sir. I'm scheduled to be 35 this year, man. All down here from here. I hear you whispering. I know what you're saying if you're older than that. Probably saying to yourself, Mike, if you think you old at 34, then what that make me? And I'm gonna be honest, we are not talking about you right now. We're talking about me. Why you being so selfish? Why old people so selfish?
Okay. Example 2, the heights of baobab trees in a grove in Madagascar are normally distributed with a mean of 50 feet and a standard deviation of 6 feet. Okay. From a group of 150 baobab trees, how many of them would you expect to be between 38 feet and 56 feet? So here's probably what we want to do. We can make ourselves our little standard deviation. We can even like put our little curve in here, right? Okay, and we can have our mean right here. And it says right here the mean is 50 feet, so 50. And then if we add a standard deviation up, that's going to be 6 more because our standard deviation is 56. So there's our high point, 56. And then if we take 50 and we go down a standard deviation, that's subtracting 6 from 50, which gives us 44. We want to get down to 38, so we got to go down one more standard deviation. 44 minus 6 gives us 58, and that's our range. We want to know how many of the baobab trees are going to fit into this range here. So it's all of these trees in this range right in here. Okay, so now if you have those, if we have these percentages from up above, that's going to help out. So let's pull those back up. So really we want this one, and that one, right? So we got 34, 34, and 13.5 is what we're looking at. So this is, let's see, we've got 34, 34, and I think it was 13.5, right? So we're going to add those all together. That is terrible because you can't see that at all. So let's try that a little bit more spread out. So let's do this. I'm going to come up with a different color here. So this is 34% of the data. This is 34% of the data, and this is 13.5% of the data. So we're going to take that 13.5 plus 34 plus another 34, and that's going to tell us about what percent we would expect to be between 38 and 56 feet, right? We pull our calculator out. 13.5 plus 34 plus 34 gives us 81.5 about is what we are expecting. About 81.5% of the trees should be between 38 and 56 feet. Okay, and then part B, find the value of K such that approximately 84% of the heights of the baobab trees are below K feet tall. Okay, so really what we got to do is we got to figure out 84. We got to figure out where's the top 16%. Okay, so if we go back to this here, let's see, 13.5, 14, 15.85, and then this out here is going to be the rest of our 0.15. So basically, from here up, that's our top 16%. So they want to know everything down in here, right? So that's going to be, let's see, this is 0.15 down here. So those two together are going to be 2.5 plus 13.5 plus 234s. Okay, so that's basically from -2 down is going to be 2.5. So we really just want to add that 2.5 more percent to our 34, 34, 13.5. So really what we're looking at here is it's going to be, I'm going to do one more different color here to try to help out. So it's going to be everything below here, right? So it's basically find the value of K such that approximately 84% of the heights of the baobab trees are below K feet tall. That's K right here is below 56, right? So K in this case is going to equal 56 feet. Well, it's K feet tall, so just 56 would work. Okay? Because 34, 34, 13.5, and then the other 2.5, that is going to add us all up to 84 total percent. Okay? Okay, that's all we have for the first half of calculating probabilities. We'll come back and do the second half here on the next video. Okay, if you have any questions on this, please feel free to ask. Thanks.